but we'll see what we do. Okay, here we go. So we are actually taking a step back. I kept sequences to be the last thing we have to study in Unit 2. We've done a lot in Unit 2. Now we're looking at sequences, back to sequences. The reason this is helpful is if you are given like a bunch of outcomes, like how much you sold each week, you had the same process, the same amount you're going to sell, you can look ahead into the future, really, and figure out, well, how much are we going to sell on day 57? Okay, if you're like always getting better every single time. Okay. So looking at this, maybe even without any of this on the board, any of the description of what we're doing, you might look at this sequence and figure out what goes right here. I want you to think about it for a second. Think about it for a moment. And then if you have an answer, think about, well, how did you come to that answer? It's not a guess. If it's a guess, it's a guess. But if you didn't guess, then think about how did you figure out what goes here? And then I want you to tell your neighbor what goes there and how'd you know? Just tell your neighbor real quick. Turn to learn about your new neighbor's name.
4 is 5. 5 plus 4 is 9. Okay.
I think it's the same shit. Yeah. All right. Let's see. Go. What goes in that spot? 13. 13? You guys feel like 13 is good? 13? All right. So I'm going to put 13 here. Let's see. Kim, how did you figure out it was? Did you get 13? How did you get 13?
Each one's adding 4 to it.
Did everyone see that? Each one's adding 4. Remember we did this in a way before. This was called the common difference, the difference between each set of numbers. And how do we find that? Give me like a way you'd find that. How'd you find it? How'd you find it was 4?
Subtract 5 by 1.
Perfect. You take 5, you subtract out the prior term, and you get the difference between the two terms. Okay? So looking at that, we know that in this case, since we are adding 4 every time, it's arithmetic. It's an arithmetic sequence. Arithmetic sequence. You might also hear that. Okay. So it's an arithmetic sequence because we're adding, and that's how we're adding every time. We're adding the common difference, the difference between each term. Now, some other options we might have, if this was instead of plus 4, say if it was this, tell me what goes here. Let's go 1, 6. Dang, I did too hard. 4, 16, 64. Okay, this we're going to call set B. What goes there in that spot? Tell your neighbor. What do you think?
16. Because it's times 4.
Right. So how about this? I go to this problem and I think about it. I'm thinking, oh, it's probably exactly like that. So I'm going to look and see. I'm going to say, well, this went up by 3, plus 3, so I'll plus 3 again, get 7. But I plus 3 again, that doesn't work. You see how you can go through it in your mind and see, am I just adding a value every time? If that doesn't work, guess what the other option is? To multiply. What do we multiply from here to here?
1 times 4.
Times 4. Times 4 gives us?
16.
Times 4 gives us?
64. 64.
Better. Good. You guys see the difference between them? And we've done this before. When we get to the Unit 2 review, we'll kind of link those things together. But for today, some things you also need to know, these 2 stars. If we're looking for the nth term, we're talking about that as the current term we're looking for. Because we're going to look at the nth term and have to look to the one prior to it. So the nth term is what we're seeking, what is the current term. And this just means, look, if this is the 5th term, right, or 3rd term, here's a sub 1. What's this?
A sub 2. A sub 3.
A sub 4. You see, we're just numbering the terms. We're just numbering the term. So if I know that this is a sub 3, and I know that a sub 3 is the term I'm looking for here, if I need to know the prior term, look what I'm going to do. It's actually easier than you think. This looks confusing, but it's not. All this is saying is the prior term is just the nth term minus 1. So what's the prior term to a sub 3? A sub 2, let's see if this works. A sub 3, which is my n value, that's the one I'm interested in. The one before that is A sub 2. You see how basic of an idea that is, right? It's just going to be the current term. The prior term is just minusing 1 from it. I just wanted to point that out because these subscripts, it's not an exponent. It's saying this is term number 1, term number 2, term number 3, term number 4. Not exponents. Okay. How are we doing so far? Thumbs up, sideways, down. All right. After we do the examples, you guys are it's gonna click. I really feel that. Here we go. What is the fourth term? I wrote this weird. We're just gonna say the fourth term, A sub 4, given the sequence A sub n is equal to A sub n minus 1 plus 5. Okay, that looks like confusing. And we know A sub 1 is 2. So what should I put here?
2.
Good. Now, let's watch. If I was looking for, let's see, if I'm looking for A sub 2, right? A sub 2, I just put my n value as 2. I'm looking for my A sub 2, is equal to A sub 2 minus 1. So what is that going to be? 2 minus 1? 1. All it's saying is the next term is the prior term. Here's the term we're looking for. The prior term is n minus one of those terms, plus 5. So let's see. A sub 2, we're going to find right now. What was A sub 1? 2 plus 5 is equal to 7. A sub 3 is just, I'm going to write it out long ways now, 3 minus 1. This is really just A sub 2, right? We use this recursive formula part. So we have A sub 3 is just the prior term, A sub 2, plus 5. What was A sub 2? 7. What's 7 plus 5? 12. All right, for this we need to find the fourth term, so we're getting there. When you guys are asked to get the fourth term, just find each of the terms. You can write your answer as problem set and just like circle the fourth term. Okay. This one, let's see. A sub 4 is the prior term, 12, plus 5, 17. And I'd want you just to circle that up. Make sure that you note that that is what we're looking for. Now, the only reason I did this is, or what this is saying, actually write this on your example right now. Let's write this. This is saying that the current term I'm looking at is just the prior term plus 5. The current term I'm looking at and interested in is just the prior term plus 5. Okay. So if I'm looking at it that way, that's what we did here with the work, and this is the work I'd want you to show. It'll get really quick once you do it. Okay. It's just saying that to get to the next term, we take the last term and we plus 5 to it. Okay. Now, if you just remember this part right here, and you're like, I don't like the A sub n, I don't like the A sub n minus 1, this is going to work for you as well. What you're looking for, the current, is the last one plus 5. Okay. All right, let's keep going. Let's keep going. Because I feel like we just need to see more. And I'll just pull these over. Oh, look at that. Looks like a plan. All right, example 2. We need to identify the missing terms. So the missing terms are going to be A sub 5, 6, and 7. So first, you want to look and see, well, is this geometric or is this arithmetic? What is happening between the terms? What's happening between 8 and 13? And then confirm it if it's the same between 13 and 18. Is it the same? Then try one more time. Is it the same? Then you could probably say, yeah, it's just a common difference. All right, I'll let you work on that a little bit. Now we're going to apply all this right here in this setting right now. So what is my common difference between 8 and 13? 5. And are we multiplying by 5?
No.
We're just adding, right? So if we're adding by 5 here, and let's see if that's confirmed. Did I add 5 and get that? Yeah. Did I add 5 and get that? Yeah. So it looks like I just have to keep doing that. And now let's look at it. A sub 5. A sub 5, the fifth term. A sub 5 is just going to be A sub 4, what?
Plus 5.
Right? So we have the current that we're looking at, the prior, and then we have a plus 5. So this right here might be the guide. This is how it's always set up. You always look at the one you're interested in, or the current one of focus. You take the prior one, you're adding something to it. Okay, that's how you find what that term is. So if I look at it, let's go ahead and knock some of these out. A sub 5 is, what's A sub 4? Let's do it. A1, A2, A3, A4. So 23 plus 5 is equal to?
28.
Okay. A sub 6. A sub 6 is going to be 20. All right, let's write it out like that. A sub 5 plus 5, so that is A sub 6 is A sub 5 plus 5. What's that equal? 33. Right? Okay, A sub 6, or sorry, 7, we already know 6. A sub 7, the last one, is going to be A sub 6, the prior, plus the 5, the common difference. And that's 33 plus 5, 38. So from that, with this kind of minimal work you have to show, this is all the work you'd have to show for this whole problem. And it's just one step at a time. We get 38 right here. Okay, so those are other interests. Okay, what's A sub 8? What would A sub 8 be? A sub 8? 43? You see it? Okay. After 2 example problems, how do we feel? Thumbs up, sideways, down. Better? Better? Okay, it's getting better. Yeah, I see some good responses in that. Okay. Looks like we do one more and then I'll set you loose. The classroom. You can't leave school. You can't. Winter break yet. All right, what are we trying to find? A sub 9. We need to find A sub 9, given A sub n is equal to 3n plus 1. Okay, then find the first 5 terms. This is an explicit formula. The difference, who can tell me one difference between this explicit formula and example 3 we're doing and this recursive formula right here? What's a little different? What's one thing you notice? Just notice them out. Nate?
The second part of the formula, that side doesn't have an A. It
Right.
has n is connected to a
Exactly.
number.
It's not as if we're relating to the current term in relation to the prior term. There's no relation to the prior term in the formula given. So this is when we are having a recursive formula. This is an explicit formula. It's explicit because it doesn't relate to a term. It relates to the number that the term has. So A sub n, if this was A sub 2, it would be 3 times 2 plus 1. You already know how to do explicit formulas. This is all you've ever done when you've been plugging in, whenever you use function notation. So all we do when we see an explicit formula like so, we just plug it in. If on the right side of the equation there's no relation to a prior term being manipulated, we know it's recursive. So with that, we just have to go and do this. A sub 9 is equal to 3 times 9 plus 1. What's 3 times 9, guys? 3 times 9 is
27.
27 plus 1.
28.
So it's really easy to find, with recursive, it's easy to find like what term, what it gives you, what value it gives you. Let's fill in these now. Fill in these. So A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. Okay. Tell your neighbor, or I want you to find A sub 1 and A sub 2 to start. And then tell your neighbor how you knew. Remember, it's it's explicit formula, so it is very straightforward. We can do that step we just talked about. So how do we find the first term? If you're not sure, how did we find the ninth term? All right, go ahead and do that up real quick.
My brain cannot go times 5 plus 4
I see, I see.
All right, that was a good little break. Check with your neighbor real quick. You got 10 seconds. I'm going to call you back quick.
4, 7, 10.
All right, bring it all back up here, please. The first term is 364.
What?
What?
It's just.
I meant 4. Sorry. That's the first joke I've done like that this whole year. What'd you think? Shaking heads. Thumbs up, sideways down for that joke. Oh, man, I gotta retire. That joke's retired. That joke's dead. Rest in peace. What'd you get for the second one? Katie, what'd you get? 7. How about the third? Anybody do the third yet? Don't walk in front. 10? 10? Same Jordan? Got 10? As you're starting to plug in, what can we start to see? A pattern. What's the pattern? What's happening every time? 3. So I don't mind if you kind of whittle in that other idea we already had. You can plug in 4 right here. You get 12 plus 1 is 13. Or you can see you're just adding 3 every time. And you add 3, you get 13. You add 3, 16. You see? So you can plug it in as far as you need to. So if I'm doing a sub 2, it's just going to be 3 times 2 because it's explicit. And that gave us 7. You could do this way if you like. Or you can go to find that common difference or common ratio, and you get there that way as well. All right. Do you see how it's better to maybe see it with the examples? Okay, I'm glad I ended with examples. Thumbs up, sideways down for this. All right. Boom. Hitchhiker. All right, what should we do for our what should we do for our please subscribe? I'm not even looking at how many subscribers I have now. It is not enough. Leah, what should we do? What chant should we do? Didn't know. Who had the best chant yesterday? What was the one you did? But
We're like, she's not dead.
she's not dead. Okay, we're gonna go.
Oh, yeah.
She's not dead. You can't kill me.
No, it's wait, you said you can't kill us. No, you can't kill me.
All right. You can't.
You say subscribe instead. Because you're telling them to subscribe.
You can't subscribe me.
No, just say subscribe.
You just do the little thingy and then subscribe.
You can't unsubscribe.
Okay. Okay. Dun dun dun. And then this is getting too complicated.
Just say subscribe.
All right. Subscribe on 3. 1, 2, 3.
Subscribe.
Man, that was easier.